Welcome to DBL Talks, the podcast where we plan to discuss everything Synergy DBL. My name is Dejan Lagafonov, and joining me today is Elaine Sun. We're developers here at Synergex, and we're very happy to be presenting and producing this very first episode.
Hello, today we're diving into simple I/O operations, which is the foundation of any data-driven application. If you're watching this, we're assuming you're already familiar with our product line and what we do. If not, go to our website at synergex.com to learn more about what it is we do.
Yeah, and this podcast is part of our broader training initiative, so beyond text alone, to provide a different format for all the new aspiring Synergy devs out there who would rather be doing anything else than reading through pages and pages of documentation.
By the end of this episode, you'll have a clear understanding of Synergy's built-in ISAM database and I/O model. We'll be linking all the relevant documentation with timestamps and links to our examples in the description.
That's right, so let's begin with the basics. So let's talk about DBL I/O, input and output. So talking about channels, what are they?
Think of a channel as a dedicated pipeline for I/O. It's just a handle. They're numbered traditionally from 1 to 1024. But in the .NET world, that number gets increased to 8192.
That's right, that range should be large enough for all your projects, but with DBL, you're also able to have dynamically allocated channels. Is that right?
Exactly. If you set your channel variable to 0 before you open a file, the runtime just finds and assigns the next variable channel number for you. And because it's the only truly thread-safe way to manage I/O handles in DBL, this is how you take a monolithic, decades-old application and make it work in modern concurrent environment without a complete rewrite of its logic. Oh, and a pro tip, always use I4 fields, DBL's 32-bit integer, for your channel variables. It will save you headaches down the road.
That's a good tip. So we've got our channel, it points to a file, and in DBL, that file is almost always an ISAM file. Can you break down what an ISAM is?
ISAM, which stands for Index Sequential Access Method, is a clever structure that gives you the best of both worlds, where you can grab records directly using a key, like finding a customer by their ID, but you can also process the file sequentially, like running through inventory items alphabetically for a report. It does this with an index file and a data file.
That's right, and the file suffixes are ISM and IS1. And you're totally correct. You can have multiple keys on a single file, which lets you support all sorts of different access patterns without needing a complex external database. It's all managed right here in the DBL environment. So let's go ahead and create a basic DBL file here with a subroutine called create ISAM, where we create a key that has where each record is 45 bytes long, and we call that key customer. So let's go ahead and run this routine. Okay, looks like that file has been created. I just want to show you what that file would look like in a dump. So right now, as you see, the ISM file is, actually no, it was the IS1 file that's empty. And it is the ISM file which holds the data structure for the key. Right now, as you see, it's perfectly empty, but once we start getting into the other operations, we will see how filling up that file and modifying the records within that file will affect the data structure. All right, so we have our channels and our ISAM files. Let's now get into CRUD, also known as create, read, update, and delete. First up, creating the records themselves. That's the store statement in DBL, is that correct?
Correct. Store is simple. It just adds a new record. The one non-negotiable is that your channel must be opened in update mode, which you'll see as UI mode spec. It's you telling DBL, I intend to write to this thing. You can't just store if you open a file for reading.
Yep, and it also has a handy qualifier called RFA, which you can see on our store command right here, which gives you back the physical address of the record you just added. That's super useful if you, for example, need to get back to that exact record later without using its key. And while store doesn't lock automatically, you can use lock to manually lock if you need to, which you can see right here, which is a parameter you can add for the store operation. It also has some built-in safety nets, like throwing in error no duplicates for duplicate keys or error too big if the record is too big, for example. So here in our demo file, we have a very basic record structure for a customer record, where the primary key is set up as an ID, first name, last name, the phone number, and the status, which we'll talk more about later on. First, we're obviously going to want to open the file. And here we have a very basic example, hard coding all the information for the customer and storing it into the file. Let's go ahead and run this file and see what the output looks like inside the data dump. Let's go ahead and see what that looks like. As you see, it added a few records for us. One thing you'll notice is that specifically in the ISAM files, the second byte value here, which as you can see is 2, indicates that there are 2 records shown. You'll see the data itself in the IS1 file right here, where you'll recognize the Jane Roe and John Smith that we added earlier.
Okay, so that's creating. What about reading data?
So for that, you're going to want to use the read operation. This is your go-to for fetching a specific record using its key. One thing I'll specify here is that we're using read s, not read, because reads allows you to fetch the next sequential record on that channel. You also have the lock qualifier, which prevents race conditions by locking the file and stopping 2 people from changing the same record at the same time. One thing I also want to point out in this example is that notice how we're using %atrim. What that is doing is that remember how we defined our name field to be about 10 characters long? What that means is that if we don't use %atrim, if our name field, for example, is going to be less than 10 characters long, that name will be padded with spaces. So there would be Jane, extra 6 spaces, and then their last name. But here, as you can see, with %atrim, we're able to very nicely format it to the screen.
Okay, so you read a record, you have locked it, now you want to change it. That's the write statement.
Yep, write updates an existing record. The key here is context. It's designed to update the record you just read and locked on that same channel. So, a demo for that would be to update every single person with an ID of 1. If you remember correctly, the only person with an ID of 1 is going to be our Jane Roe here. So we're going to set her flag from active to inactive. So let's go ahead and run this. All right, let's see what it changed. Looking back, let's see what it did. We're going to look at our dump for IS1. As you see here, it removed the active flag and replaced it with a non-active flag.
This brings up a neat design concept, immutable keys. Why would you ever want a key that can't be changed?
Well, it's all about data integrity. Think about the primary key, for example. In our update records demo, what we did is we read this ID, which we set up as the primary key, and we're simply modifying the status of that record. However, if we try to modify this primary key of the ID, that user might as well be lost because you won't be able to find them in your records when you read them.
Okay, last of the operations is deleting. I usually see 2 main strategies here, soft deletes and hard deletes. Can you walk us through those?
Yeah, absolutely. A soft delete, which is your more cautious approach, where you're not actually deleting the data, or in this case, we wouldn't be marking the data for deletion within the data structure. So this would be, for example, like setting this flag for the status to from active to inactive, where the user would be filtered out, for example, in a read. So let's try to read this record again. Now that we set the status of the first record to inactive, you'll notice here that Jane has been deleted. Now this leads us to the hard deletes, which is what you want to do to actually delete a file. So here's what that looks like. We're searching for every single record that is non-active. So this would be our Jane here. And running this file, we will see Jane entirely deleted from the file. So running this. So as you saw, it just deleted a record. So let's go ahead and see what happened to that data inside the dump. So as you see here, what changed is the primary key of Jane was changed to show that she's no longer the first record. Let's try to add a new record with an ID of 3. Let's call this person Daniel Agafonov. He's going to be an active file, so let's see what that looks like. All right. Now let's take a look at what happened here. As you see, our Jane Roe was replaced with Daniel Gafonov, and the John Smith stayed the same.
Okay. Beyond basic store, read, write, delete operations, DBL has more nuanced ways to get around a file. For example, what's the difference between find and reads?
Well, find is just a pointer. It just points the file cursor on the record that matches your key. It doesn't actually retrieve the data in your program's memory. You have to do a subsequent read for that. And by default, find does not lock the record, so that's something you have to account for. Now, in regards to reads, if you remember, we used in our example when we read the data from the ISAM file, we used read S, not read. Read S stands for read sequential. So it's what you would use to walk through a file in order, just like we did. It retrieves the next record according to the key you're using. So it's incredibly efficient for things like generating reports or running batch updates. The key thing to remember is that it doesn't filter. So if you're reading alphabetically for customers in California, it will also give you Colorado. So you have to check for that in your code.
Good. Now this brings us to a really powerful feature called partial key reads. How do those work?
That's a good question. Because ISAM keys are ordered, it's fantastic at range queries. So a partial key lets you read you, for example, the first part of a composite key. So imagine a key that has region plus department, or the area code of a phone number stored in a single field of a record. You could do a partial key read just for the West region or just the area code to see that the user is in the United States. And let's just do a demo for that right now. So let's say, for example, that we want to be able to search through the customer's last name. So for my example, let's say if we would do a partial search on AGA, it should be able to return this entire record of mine. Because this requires you to create a brand new ISAM file to define a key on that last name, this will require some planning ahead on how you what you want to set up as a key. So I'm going to do this the fast way. I'm going to say create a key with a start value of 16. Start is going to be 16 because it's on the 16 byte that the last name starts. Length is going to be, it's 10 alphas. And that should be it. So we're going to call this partial key. There we go. Red squiggles because I didn't tell it that I added a second key. So let's go ahead and create a brand new ISAM file. One thing to note is that it doesn't matter how we add data into this file because we only change the structure of the key, basically what defines the key. But it does matter how we're going to be reading the data. So that is one thing. The next thing we're going to be updating to say that because we want to search the last name, let's create a partial key. Partial key, say it's an alpha 10. We're no longer going to need this here. And let's see, so let's say we want to search our partial key to be a AGA, just like before. That's right, this is what we're searching for. So now let's go ahead and write this to the terminal channel. Channel say partial key. And so now we're actually going to want to search for the data itself. So we're going to find from the customer file. We're going to search the HM value of the partial key based on key num1. And we're going to read the customer file based on our customer record. And now we're just going to, as before, we're going to define our end of file. It's going to be done, and error is also going to be done. Now what we're going to want to do is going to be to write what we find to the terminal channel. And we're just going to finish it off with a go to our done. All right, I don't think I missed anything. So let's go ahead and run this. So here, as you can see, we're reading our data just fine. I just simply forgot the %HM.
I've also heard a good habit here is to use variables for key numbers instead of hard coding them.
Yeah, that's absolutely right. And I would even recommend to save yourself the headache and not do what we just did and hard code everything, but instead use variables just like you would in any other language. It will save you a lot of headache down the road. So wrapping up, we've covered the basic building blocks of channels, ISAM, and we've gone through the core CRUD operations.
There's a lot more to learn from here as there are many tools for developers to give them everything they need to build highly optimized and reliable applications, whether you're modernizing an old system or building a new one on .NET.
And I think it really shows that in a world driven by data, just like the one we live in, understanding how your tools fundamentally interact with that data isn't just about syntax, it's about giving you the tools to process all this data. And a little bit of trivia for our listeners at home. We actually spent a few hours trying to figure out how to use the no-fill qualifier on, I think it was the reads operation, where we were trying to trim the data, but we realized only after a few hours that it was entirely the wrong use case, and it was just easier for us to use %a trim. So I hope that saves you a little bit of headache down the road. Thank you for joining us on this episode of DBL Talks. Until next time.